LearnCity. My name is Praise and I'm the mathematics tutor, and in today's class we'll be talking about geometric progression. Geometric progression, also known as GP. Now, a sequence in which each term is obtained by the preceding term by multiplying or dividing by a constant factor is called the geometric progression. Now, the difference between arithmetic progression and geometric progression is, for arithmetic progression, we can either subtract or add, while in geometric progression, we can either multiply or divide. We can either multiply or divide. For example, here we have 16, 8, 4, 2, and 1. So we can just say 16 over 2 over 2 over 2 over 2 over 2. So 16 divided by 2 is 8. This is 4. This is 2. And this is 1. So this one is dividing by 2. Let's check 1, 3, 9, 27, and 81. When we multiply, 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Now, for the nth term of a GP, if the first term of a GP is A and the common ratio is R, then the first three terms are, when R, the first term is A. For arithmetic progression, we have our common difference, and for geometric progression, we have it to be common ratio. So we have our common ratio to be R. So for the first three terms is now U1 equals to A, U2 is AR, and U3 is AR squared, U4 is AR cubed, U5 is AR raised to power 4, in which in general our UN is now AR into brackets n minus 1. So for the nth term, we have it to be AR into brackets n minus 1. And today we solve 3 examples on geometric progression. So the first example says, find the 8th term, the 34th term, and the nth term of a geometric progression 10, 20, 40, and 80. So now for this one, are we dividing or we are multiplying? So we can have it to be multiplying, which is 10 times 2 times 2 times 2. So which means our common ratio is 2. So we have our 8 to be 10 and our common ratio to be 2. Now, the first one says we have to find our 8th term. So our 8th term is UN, which is ARN minus 1. So our U8 will now be AR8 minus 1. And our A is 10, our R is 2. So we have U8 to be 10 times 2 raised to power 7. So 10 times 2 raised to power 7. Have it to be 10 times 2 raised to power 7 for our 8th term. So 2 raised to power 7 is 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2 is 32, 32 times 2 is 64, and 64 times 2 is 128. So we have our unit to be 10 times 128, which is 1280. We have it to be 1280. Now, for the 34th term, we have U34 to be ARN minus 1. We have our A to be 10 and our R to be 2. So we have 10 times 2 into brackets 34 minus 1. We have 10 times 2 raised to power 33, and 2 raised to power 33. We have it to be 10 times 8, 580. Okay, 8, 9. We have 9, 3, 4, 5, 9, 2. this is 2 raised to power 34, 10 times 8, 5, 8, 9, 9, 3, 4, 5, 9, 2. So multiply by 10, we have it to be 8, 5, 8, 9, 9, 3, 4, 5, 9, 2, 0. This is our 34th term. And for the nth term, we have it to be un into bracket arn minus 1. So we can just have it to be un equals to our a, which is 10, to n minus 1. So that is 10 times 2 n minus 1. Now, following the laws of indices, making use of the laws of indices, we can have it to be un to be 2 times 5 times 2n minus 1, where we can write it to be 5 times 2 times 2n minus 1, in which you can also write it to be un equals to 5 times 2n. So that will now be minus 1 plus 1, using this for our laws of indices. So this is plus 1 plus 1. So we have our un to now be 5 times 2n. So our un is 5 times 2n. We have it to be 5 times 2n. Now, for the second example, we have if the first, second, and last term are 41 minus 20 and 12,500. First term is 41. Second term is minus 20. And last term is 1,500 respectively. Find the number of terms in the GP. We have to find the number of terms in the GP. So now we need to first look for our common ratio. We need to look for our common ratio. So where we have our a to be 41. Now for our next term, our second term is usually AR, which is minus 20. Now AR n minus 1 is 1 to 500 for the last term. So our common ratio is usually our AR over A. So our AR is now, our AR is 4, sorry, not 41. Okay, so it will now be AR over A. So we have our R to now be minus 20 over 4. So we have here to be R to be equals to minus 5, because our first term is because our first term is 4 minus 20 and 1 to 50. So this will now be 4 times minus 5 is minus 20. This one times minus 5 will be plus 100. So we have next one to be 100. Now we've gotten our R. So where we have UN to now be ARN minus 1, where we have our UN to be 12,500. So we now have it to be A, which is 4, our R, which is minus 5, and N minus 1. So we have it to be 12,500 equals to minus 20 Okay, so we have this to be 4 into brackets minus 5 n minus 1. So this 12,500, you can easily square root it to 5 raised to power 5. Or we can easily get it as divide through by 4. So we can divide through by 4, where we have 1,500 divided by 4 equals minus 5 and minus 1. So 4 here is 3, in 5 is 1, in 10 is 2, and in 20 is 5. That will now be minus 5 and raised to power minus 1. So we have 3125 equals to. So from here we can just approximate, can have it to be 5 raised to power 5 equals to minus 5 and minus 1. So using the laws of indices, we can have it to be, here we'll cancel this one, it is supposed to be minus. So because have it to be minus 12,500. So this will now be 5 equals to n minus 1. So that will now be 5 plus 1 equals to n. So our n is 6. So basically our n here is 6. It is not actually 12,500, it is minus 12,500. You have it to be minus 12,500. So from this minus 12,500, we divide through by 4. When we divide through by 4, we get minus 3125. When we get minus 3125, that will now give us minus 5 raised to power 5, where we now use the laws of indices. When we have minus 5 to be equals to minus 5, where we have the same base, we'll cut it and we have it to be n plus 1, which is 6. And this brings us to the end of our class on geometric progression. Do subscribe to our YouTube channel and I will see you in our next class. Thank you.